Welcome back. In this video, we are going to solve problem 14-13 that is taken from chapter number 14 Energy Methods and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the maximum force P and the corresponding maximum total strain energy that can be stored in truss without causing any of the members to have permanent deformation. Each member of truss has a diameter of 2 inch and is made up of A36 steel. So you can see this is truss clear that is acted upon by a load P. So we will find this P load clear and the maximum total strain energy stored in this truss. Each member has a diameter of 2 inch. So you can see I have written all this and it is equal to 2 inch which is D and they are made up of A36 steel. So let's start with the solution. So first step is that we will find the normal forces in this member, and this normal forces they can be obtained by using method of joint. So we will apply method of joint at various joint in order to find the axial forces. So let's take this first joint B. So you can see due to this load P, this will elongate clear and this will behave like this. So this member CD will be in tension. Similarly, member BD and CD will be also tension. So as a result, member BD will exert force in this direction over this point, and similarly, member AB and CB will also exert force in this direction at this point B. So we will draw the free body diagram. So first joint B, I will write joint B. So let this is your point B clear. So where you have P load which is acting downward clear. The force that member BD will act at point B will be upward. So this will be FBD. Similarly, the force acted by AB over point B will be FAB. And the force that member BC will exert at point B will be FBC. Now applying equation of equilibrium that sum of all forces along x direction must be equal to 0 and force in this direction is taken as positive. So you can see horizontally two force, one in this direction, another one in this direction. Their sum must be equal to 0. So minus FAB plus FBC is equal to 0. So it means that FAB is equal to FBC. Okay, so this is your equation number 1. Now we'll apply method of joint at joint D. But before that, we will also apply another equation of equilibrium that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So FBD is upward minus P is downward. Their sum must be equal to 0. So FBD will be equal to P. And this is your equation number 2. Now moving toward joint D. So you can see this is joint D. At joint D, the force that exert this member BD exert will be in downward direction. Similarly, this member will exert force in this direction and this member will exert force in this direction at point D. Why? Because you can see P is downward which is causing tension in this. As a result, this will go downward causing this to compress, and this according to Newton's third law this will exert force in this direction. So we will draw the free body diagram of joint D. This is your point D where one load which is FBD will be downward. This is FBD clear. This is your force FAD and another one is FCD. This is FCD. And you can see they both are making angle theta. So this will be angle theta. This will be also angle theta. Okay. Now applying equation of equilibrium. So first equation of equilibrium is that sum of all force along x direction must be equal to 0 and force toward right side is taken as positive. So you can see it will have two component. One will be this one, another one will be vertical. So this component will be equal to FAD cos theta and this component will be FAD sin theta. Similarly, it will have also two component, one along x and other along y. So this will be FCD cos theta and this one will be FCD sin theta. How we will find sin theta? So you can see this base is 3 and this height is 4. So by using Pythagoras theorem, 3 square plus 4 square under the root will give you AD length or CD length, and that will be 5 feet. So this will be 5 feet, this will be 5 feet. Now cos theta is equal to 3 over 5 because base over hypotenuse, and sin theta will be equal to 4 over 5. So we will apply this equation of equilibrium, that sum of all forces along x direction. So you can see along x direction this and this force are acting. So I will write FAD cos theta minus FCD cos theta is equal to 0. So what we will get is that FAD cos theta will be equal to FCD cos theta. Cos theta will be cancelled. So FAD is equal to FCD. And this will be our equation number 3. Now applying another equation of equilibrium, that sum of all forces along y direction must be equal to 0 and force upward is taken as positive. So you can see two forces which are acting upward and one force which is acting downward is FBD. Their sum must be equal to 0. So minus FBD plus FAD sin theta plus FCD sin theta is equal to 0. And FAD is equal to FCD. So I will replace this FCD with FAD. Okay. Is plus minus FBD. So FBD will be equal to 2 times FAD sine of theta. And 2 multiplied by FAD and sine theta is 4 over 5. So 4 over 5. So what you will get is that FBD will be equal to, we are interested to find out FAD. So FAD, because FBD is equal to P. So FAD will be equal to 5 multiplied by FBD divided by 4 into 2. Clear? So we will get FAD will be equal to 5 over 8 FBD. This 5 by 8 is equal to 0.625 and FBD is equal to P. So I will get FAD is equal to 0.625 P. And this is your equation number 4. And we will apply a joint method of joint using point C. So you can see you will be having reaction force due to roller support Cy, and the force this member will exert at point C will be in this direction, and this member BC will exert force in this direction over point C, and we will draw the free body diagram. So joint C. So this is this is point is C. So vertical direction is Cy. Clear? The horizontal force by member BC will be FBC in this direction, and this member CD will exert force in this direction. This is FCD, which is making angle of theta. Clear? So we'll apply equation of equilibrium, that sum of all forces along x direction must be equal to 0, and in this direction force is taken as positive. So you can see this will have two components. One is this along vertical and this will be horizontal, and this component will be equal to FCD cos of theta. Clear? So I will write FBC negative plus FCD cos of theta is equal to 0. So FCD cos of theta is equal to FBC, and cos of theta is 3 over 5. So I will write FCD is into 3 over 5 is equal to FBC. Clear? So FCD, okay, you can see FAD is equal to FCD. So I will also write FCD will be also equal to 0.625 times P. Clear? So you can just put the value over here. So FBC will be equal to 0.625 multiplied by 3 over 5, and that will give you 0.375 times P. This is FBC. Okay. Now you can see this member, due to this load, this will be in tension, this will be tension, this will be in tension. This member, these members will be in compressions. Clear? So you should know about this. Let's proceed further and we will find the area as well. So area is equal to pi by 4 d square, since d is same for all, so which is 2 inch. So pi by 4 2 square will give you pi, and unit will be, area will be pi and unit will be square inch. Now we are given that it is made up of A36 steel, and you can see the largest load in this member is P, which is FBD. Rest all the forces are multiple of P, which is less than 1. So maximum load will be taken by member BD. So I will write member BD is critical. Why it is critical? Since it is subjected to greatest normal force or largest normal force, and that normal force is P. Okay, and we know that yield strength, which is the maximum load, is equal to maximum load in member F, FBD, not CD, it is BD, divided by the area. So we will need yield strength of that. For that you will go to the property table and you can see that A36 steel having yield strength in tension is 36 KSI. So note down this value, 36 KSI. So I will write 36, clear, is equal to PF. BD is equal to P, so P divided by A. So from here, this P will be equal to 36 multiplied by A and 36 multiplied by pi. So you will get P will be equal to 113.10 kip. Or you can see that in short, P is equal to 113 kip. So this is the largest load P that can be applied on truss. There. Now next we will find the strain energy due to axial loading. So for that I will move, what I will do is that I will copy it, or I will copy all this and we will move toward next page so that you can easily pick the value of every force. So I will copy it, paste, and then we will resize it. Let me resize it for you. Okay. Now we will find the strain energy. So how you will find strain energy? We know that strain energy due to axial loading is equal to sum of F square into L divided by 2AE. So for member, different member, A, B, B, C, C, D, D, and this will be equal to strain energy axial. For member AB, it will be equal to FAB square length of AB divided by 2 times area is same and E is same, plus for member BC, it will be FBC square LBC divided by 2AE, plus for CD, it is FCD square LCD divided by 2AE, plus for member AD, it will be FAD square LAD divided by 2AE, plus for member BD, it will be FBD square LBD divided by 2AE. AE. If you take AE common, so I will write strain energy due to axial loading will be equal to 1 over 2 times A is pi and E for A36 steel. So I will go to the property table, and it is for A36 E is 29 into 10 to the power 3 KSI. So I will write it 29 into 10 to the power 3 KSI, and we will left with FAB. So FAB, you can just put FAB. Okay, so you can see P is this one. So FAB, where is FAB? So you can see FAB is equal to FBC, and FBC is 0.375. So 0.375 times PP is 113 kips, and this will be equal to FAB will be equal to 42.41 kip. Similarly, FAD is equal to FCD. You can see this is, and FCD is 0.625. So when you multiply P, so when you multiply it, you will get it 70.69 kips. And the last one is FBD, which is equal to P, and that is 113 kip. Okay, so FAB is 42 kips. So 42.41 square, 42.141 square into length of AB. Length of AB is 4 feet. Let me check it. Length of AB is 3 feet. So 3 multiplied by 4, convert it into inch, plus FBC square. So it is also 42.41 into length. BC is also 3 feet. So 3 multiplied by 12, 3, 3 feet, 3 into 12. Okay, this is also not 4. This is 3 into 12. Okay, let me check it. FAB is 3 feet, FBC is 3 feet. So 3 into 12 plus FCD. So FCD is 70.69 square. FCD and AD, these are 5 feet. Clear? So 5 feet multiplied by 12 will convert it into inch, plus uh, FAD. FAD is also 70.69 square multiplied by 5 multiplied by 12, and the last one is FBD. So FBD is 113 square multiplied by FBD. BD is 4 feet, so 4 multiplied by 12. Clear? And when you solve this, you will get strain energy due to axial loading in this truss will come out to be 7.31371. Unit will be kips into inch. Or you can say strain energy due to axial loading that is stored in truss without a permanent deformation of any member will be 7.37 kips into inch. And that was all about this problem 14-13. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help them in learning and clearing their concept. Thank you for watching.